Welcome back. Hopefully you've created your own graph here out of a plot or figure. See, again, I'm mispronouncing all these different words. Hopefully your prices aren't cheaper because the nut butter game is very competitive these days. So in the last video, we finished off on bar graphs. There is actually a horizontal bar graph. You may have seen this before. So if we go fig ax equals plot.subplots, and we go ax.bar h for horizontal, we're going to pass it just the exact same thing as above. Nut butter prices.keys and nut butter, because we've got our saved dictionary up there. Yours might be a different name. Dot values. Oh, what's happened here? Unhashable type. Dict.keys. I actually did look this one up. In this case, for the bar horizontal, we have to turn our values here into a list. Now, how did I find that? Well, I did our search method. I looked it up. I pre-baked it. I had to make sure that I was getting things right for this one since we messed up in the last lecture, but that's okay. So we go there. We got a horizontal bar. Same information, just presented horizontally. Now, which one should you use? It's more of a personal preference here. I like this one. It's vertical. Sometimes you'll want a horizontal bar. There are other plots that look better on a horizontal. We'll have a look at some of those in potentially a future video. Well, let's check out what have we done so far. We've done line, we've done scatter, we've done bar. Let's do histograms. What's a histogram? Well, let's see it first. Remember, if in doubt, run the code. We'll make some data. We'll go x equals np.random.randn, and we want 1,000. What does randn do? Shift tab. Return a sample or samples from the standard normal distribution. Now, what is a standard normal distribution? Let's have a look. Normal distribution. We'll go here. Okay. In probability theory, the normal or Gaussian distribution is a very common continuous probability distribution. Whoa, that was a bit of a mouthful. But what you really need to know is a normal distribution are these curves here. So in the middle here, this is the mean, and the distance between the mean and here is the variance. And so whenever someone refers to a normal distribution, they're referring to one of these kind of like symmetrical curves, and they can appear anywhere on the x-axis like this. That's what you need to know about a normal distribution. So if we go in here, this is going to make 1,000 random samples that would fit within this curve. But if in doubt, run the code. Let's actually see this in action. Fig ax equals, because remember, every time we want a new plot, we create a new plot. Subplots, ax.hist, x, little semicolon at the end. So what we've done here is we're doing a histogram, but oftentimes you'll see it shortened to hist. So if you see hist, probably referring to histogram. So if we do that, there we go. We've got a bumpy curve. It's not as smooth as this one, but you can kind of see it's got the same shape. That's what we're after. Just that same shape. Beautiful. Okay, now we've covered histograms. Now, what if you wanted to get multiple plots happening at the same time? We've referred to this before as subplots. Well, the beautiful thing is we can make them with the command we've been using. Now, again, there's two options for histograms, because we want to make this a bit more communicative and plot it. There we go. We're in the habit of being communicative, so we've got to finish off that cell before we start a new one. Two options for subplots. Let's do that. Make a little heading, and then we'll go subplot, option 1. Wonderful. Okay, we're going to create fig. Now this is going to look a bit different to what we've been doing. Ax1, Ax2, and you're like, whoa, what's going on here, Daniel? But don't worry. Follow along, and we'll explain in a second, because remember, we're in the habit of just seeing what happens with the code. N rows equals 2. Hold on, we've never passed a keyword argument to this. Well, now we're going to pass 3. We're living dangerously, I told you. Fig size equals 10, 5. Well, my 5 key is a bit sticky, you know. So if we look, what is this actually doing? Let's run it. Whoa. Look at that. Now, can we infer what's happening here without even looking at the docstring? So we've got fig, comma, and then a tuple, which is of tuples of x1, x2, x3, x4. So can you guess what's happening here? And we've got some keyword arguments. N rows equals 2, n cols equals 2, fig size equals 10, 5. What do you think's happening? N rows equals 2, 2 rows, 2 columns. I've got x1 maybe, x2, x3, x4. Well, I think that would be pretty spot on if that's what you guessed. That's what I guessed. So here we go. Let's read. Create a figure and set of subplots. This utility, yeah, we've read that before. N rows, number of rows, columns of the subplot grid. Beautiful. Now let's see, how would we get data on here? So let's do this. Plot to each different axis. Let's see this in action. X1, dot plot. Let's go X. We've got some X data, I think. That'll probably do. Let's see what happens when we do plot it. Boom. Straight line. Wonderful. We can do that. Okay. So yeah, X1 is this top left one. Okay, that makes sense because it comes first. Can you guess which one is X2? Well, let's see and find out. MP, let's make some more random data. Random.random, 10, and we'll do random.random again. 10. And semicolon. Ah, okay. And see, we've created a little scatter here. So that's X2. Wonderful. X3, let's do a bar on this one. We're going to start mixing this up, you know. Nut butter, can I do tab complete? Nut butter prices, yes I can. Dot keys, nut butter, we want the values on this one. Dot values, wonderful. And let's see what happens. Beautiful, we're starting to fill out our subplot here. This is wonderful. X.4, we want hist, and then we want mp.random.rand and normal distribution. We checked that out before. There we go. Boom. Now we have a subplot with 4 different subplots. Now again, this is just some dummy data, except for this. This is real stuff right here. This is Dan's Almond Butter Store. And now you could add some titles to these axes, much like we've done up here with this set command here. But this is just to exemplify one way, option 1, we'll do option 2 in a moment, maybe in the next video, of how you can get more information on the one figure. So if we look back to our anatomy, we go here. It's still a big figure. This blue square, if we converted this blue square, it's going to follow around this. But now we've got axis 0, axis 1, axis 3, axis 4. But it's actually axis 0, 1, 2, 3. But we've named them differently. In reality, we should have probably 0 indexed these, but I've just gone 1, 2, 3, 4. But now you're starting to see, if you wanted to get more information in just one image rather than having 4 different figures, you can see you can do that with subplots. The reason why we've been using this command is that you can create single plots or multiple plots with the same command. That's that flexibility we were talking about of the object-oriented API for Matplotlib. So this is option 1. Before the video gets too long, we'll pause it there and we'll have a look at option 2 in the next one.